Hi, everyone. Thanks for joining us for our next session, Fine-Tuning the GPT Model Series for Agent Applications with WNB and Azure OpenAI Service. My name is Anna. I'm an event planner for Reactor, joining you from Redmond, Washington. Before we start, I have some quick housekeeping. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional, and on topic. Keep an eye on that chat. We'll be dropping helpful links and checking for questions for our presenters to answer live. Our session is being recorded. It'll be available to view on demand within 24 to 48 hours. With that, I'd love to turn it over to our presenters for today. Thanks so much for joining us.
Hey everyone, good morning, good afternoon, and good night, or wherever you're coming to us from. I'm super excited to be here today for today's Reactor Talk. My name's Gerard. I'm one of the senior software engineers from Microsoft OpenAI fine-tuning team. And joining me today from Weights and Biases is Anish. We're super excited to be here. Before we get started, I got to be completely honest with you. I have had an absolute blast this year working with the Weights and Biases team. It's been one of my absolute highlights, and I can't wait for you to see what we've been working on and how you can use it to streamline your fine-tuning process. Let's see if I get the next slide. All right, before we get going, let's do a bit of an agenda. So, just to get the schedule for what we're doing, I want to start with what's fine-tuning and why it's an important part of your LLM toolbox. Then, in case you missed it, or you couldn't consume what was going on at Ignite all in one bite, let me let you know what's been going on in the Azure OpenAI fine-tuning team in the last couple of months. Following that, Weights and Biases is a natural fit for Azure OpenAI, and we'll tell you why. Moving to the fun stuff, we'll do some demos, and purely for the YouTube clicks, I'll walk you through how to set up your Azure OpenAI fine-tuning ecosystem so that you'll be ready to send your own fine-tuning metrics to Weights and Biases. OpenAI fine-tuning metrics, I should say. From there, Anish will take us off the tarmac and get us into cruising altitude, and you demo the true power of the Weights and Biases integration. While we're here, please throw your questions in chat, and we'll get to them and help you out as you can. So what is fine-tuning? You might have a natural first question of, Gerard, did you steal these slides from a different presentation? Absolutely, yes, I did. I'm in back-end development, not marketing. So if you haven't already, please go check out the Microsoft Ignite recordings. Some of these may be familiar to you, and a lot of people who are very good at explaining things can also help you out there. But while we're here, fine-tuning is simply using additional training data on an existing model to improve its performance on specific tasks or its capabilities in some way. One thing that I like to think about is that it doesn't just have to be the base model that you can fine-tune. You can fine-tune a fine-tuned model. For example, if you already had a fine-tuned model which specializes in some sort of jargon or shorthand, which is specific to your domain, you might decide to fine-tune it again to improve its reliability on the specific functions and tools that your use case is using. Why would you consider using fine-tuning? Well, ultimately because your business, your app is unique, and therefore it needs a unique, tailored, dare I say, bespoke solution. And this is in a number of different avenues that this can be solved for. There are a number of other tools which you can use to improve your LLM performance, such as prompt engineering, RAG, or pre-training. Each of them has their own benefit, but let's dive into the benefits of fine-tuning real quick. Fine-tuning is generally great for scalability. When you fine-tune your model, you can get it to a point where it uses much less tokens. And because you can teach the model how to answer better without using such a large input prompt. And this means fine-tuning has an upfront cost, but generally over time, the cost will come down as you reduce tokens for each call. Reduced hallucinations is another opportunity. But by providing the real-world specifics of what your app is doing, your model can better understand what you want it to do, and thus reduce the answers that it's getting from a more generalized approach. Improved reliability is another great opportunity, again, based on how you can scale to specific tasks that you're looking for it to do. Efficiency based on less tokens, less prediction loops means quicker responses for you, and tailored to your specific solutions. So specific language needs, programming otherwise, functions and tools which are critical to your application can be much better. The current Azure OpenAI models are highly powered, but highly generalized, not the rich experience your solution may need. Okay, so looking at going deeper in what fine-tuning can do for you. We've already talked about reducing the prompt length. In this case, you started improving your response accuracy and format with prompt engineering, and that's a powerful tool which has led to great results. But now you have no tokens left over for your answer. Time to fine-tune some response formats into the model itself. Now your model will give you the chance for your model to respond with a deep and insightful response your users need. Fine-tuning is also an opportunity to teach new skills, to move from the general to the real focus, your capabilities that your users move to the capabilities that your users focus on. Improving tool use. This is an opportunity for you to teach your model to use the tools and agents that you've provided in the best way possible. And finally, domain adaptation. This is how you can capture the specific domain you operate and to avoid the confusion. A few examples of domain adaptation which you can use would be, for example, Azure OpenAI GTP models are really good at using Python, but for my job, C#, it's not quite as good, particularly in using unit tests. And this is something that you can better fine-tune your model to do. And the specific data of your use case is also an opportunity where you can fine-tune to improve. So what is new in Azure OpenAI fine-tuning in the last couple of months? In the last couple of months, we've had some great releases, including 4.0 and 4.0 Mini, which are now out and available for your fine-tuning needs. These models currently carry support for vision and also structured output. And so you can teach your model how to get the most out of these opportunities. Also, while we're here today, we're going to talk about the weights and biases integration, which is another great offering we've provided. And particularly for enterprise customers, the release of provisioned and global standard deployments is a fantastic opportunity where, using provisioned deployments, you can have a consistent offering of compute for your needs. So it's always available and ready for whenever you are. And through global standard deployments, you can move your fine-tuning models between the regions that you're operating in rather than having to fine-tune in each region. A particular interesting release, this feature that was announced at Ignite is our distillation capabilities using stored completion evals and fine-tuning. So this is, I think, a great step forward for Azure OpenAI, and we've made great strides to really empower how you can use fine-tuning. One of the big problems with fine-tuning is finding the large data set and making it really high quality for the use cases that you're using. But for many users, they already have apps or applications running that are busy getting and doing exactly what your customers and users are asking you for. And this is a great source of data that you can use to further improve, fine-tune your models. And this is where the stored completions opportunity steps in by capturing, by enabling your model to capture and log the model inputs and outputs. We can capture what your model is doing. And then these inputs and outputs can be queried and filtered to get the data, which is most important to your use cases. Additionally, by using the new public preview evaluations feature, you can additionally improve your data by adding further validations to guarantee that the data that you will fine-tune your model with meets the needs of your use cases. Once you've taken the data from your current models in production, queried, filtered, and evaluated, you have a very high quality data set that you can do further fine-tuning on your model with. And then you'll have a high confidence of the quality of the model that you're producing. Okay. So as we move into the presentation, into the demos, I'd like to give some ideas on where the real power of weights and biases and the Azure OpenAI Service integration comes into play here. We're using the power of weights and biases to get comprehensive experience tracking, along with the experience that we built together for a seamless integration and the scale infrastructure of Azure. We can create a great experience. And additionally, weights and biases provides leading in collaboration, version control, and real-time monitoring and evaluation. So let me step in now to show you how you can set up your integration with weights and biases. Let me just change my screen. So there's some really great resources that I can share on this, but let me walk you through the steps on how you can get your Key Vault and integration set up. So the first thing you want to do, I'm presuming, let me just check we're the right stuff. We're not at the right slide. Okay, this is much better. Okay, so once you've got, I'm going to presume you've created your Key Vault and created your Azure OpenAI resource. For this, what we're going to need to do is change the identity to be system managed. So for this, you've got your Azure OpenAI resource. We've got identity down here, and we can set system design as on, and we'll save that. Give that a few seconds to go. Man, a bit of a slow morning this morning, I guess. But that's all right, we'll get there when we get there. While that's loading, we'll need to make a few changes to your Key Vault. Now, there's a few options for how this works. Generally, our current advice is that the Azure Key Vault has two options for how you can do permission models. One is the Azure Role-Based Access Control, which we're amending, which is the newer model. Previously, we had the Vault Access Policy. We recommend you stay with the RBAC. To add the permissions we will need to link Azure OpenAI Service to the Key Vault, you'll need to go to Access Control and add permissions. Let's just check that this is all done. All right, we have the system assigned identity set up here. So the permission that we're looking for here is Azure Key Vault Secrets Officer. So this here, we can hit next, manage identity, and we'll try and select the members here. So here we're looking for Azure AI Services. Oops, sorry, not AI Services. Azure AI OpenAI. And we'll look for this demo account that I've set up. and select that. Hit next, review and assign. And this will allow your Azure AI resource to access the Key Vault. While we're here, I'm just going to check my access because I also need to make changes to the Key Vault. So I also have this Key Vault Secrets Officer here. You would need to do that for yourself initially so that you can add the key. With that, we would need to add the secret itself. So in assurance that I will not show any secret keys, I will not actually add the secret, but you can trust me that it's just a simple matter of creating the secret and adding it here. Okay, so what we will need to move forward here, overview, is also, in addition to the secret name that I've copied, is also the Key Vault URL. With that, we should have this set up correctly. Now the Key Vault is ready and connected to your Azure OpenAI resource. Let's open this up and have a look. All right, so with fine-tuning, with the new weights and biases integration, we have this Manage Integrations button here. And this is where we can enter our details. So that's the Key Vault, my Key Vault. It's not this resource ID, it's just the link, it's the URL. And secret name. Now, there's not any validation here to ensure it's correct. So, once you do this, be aware something may have been wrong and you may have to debug further. And so to prove to you that this is set up and working, we'll see if we can create a fine-tuning run just to see the integration is working. So we have the model suffix, we'll call this the Reactor 24/1012. And here is the way we can send the metrics to weights and biases. We'll need a project name. So add this in here, and this is how it'll show up in weights and biases. Display name, we can add whatever we'd like there, but we'll just leave it for now. Training data. Oops, I regret not have uploading data ahead of time. Really feel like I did myself a disservice by...
And while that uploads, I guess I can kind of make a comment about like the file itself. So the JSON-L here is of the same format that you'd see in the standard OpenAI interactions. So you'll see, say, the role of user assistant, and then actually have the content. So a lot of times you end up naturally collecting a lot of those back and forths that you have with your released deployments of your models, either on Azure or whatever LLM service that you tend to use, and aggregate them into these JSON-L formats that you see Gerard uploading right now. So it's really easy to actually go ahead and curate this data that you want to do in fine-tuning on top of. And we'll talk about that more later. But I think Gerard's data has uploaded, so let's go and see what's happening.
Yeah, so I'm just going to submit this now, and we should see now that we're going to kick up the fine-tuning run. This is the point where if there was an issue with your integration, you would get an error which would tell you if there's a permission issue or the key. But at this point, my fine-tune run is ready to go. And this means that once the run reaches the right point, the metrics will get sent to weights and biases. And at this point, I'll ask Anish to take over and show me what those metrics look like.
Awesome. Thanks, Gerard. Let me just share my screen right now. Yeah, so hopefully you're able to understand some of the concepts around fine-tuning and also how to go ahead and set up this integration. I'm from Weights and Biases, and so I'm going to give a little spiel about what Weights and Biases actually is. And so from our end, we're an AI developer platform who have a collection of tools to allow you to actually create really powerful models. So you can go ahead and actually create your own LLMs from scratch and make sure you have all the statistical information alongside any important information about that process in one location. And if you ever want to take an LLM and do something like we see here, we're going to talk about more, fine tuning, then that's also all those tools that those builders are using are all available here. And so I'm going to go ahead and actually walk through a real example, but in a more of a, I guess almost in a way someone has mentioned in chat, similar more like transfer learning. So how to teach LLMs new behavior for something that's not really that good at right now. And then we'll take it a step further, and then we're going to go ahead and actually understand if our model did better by actually understanding the outputs of those models and evaluate it. And then we'll talk about an agentic style workflow. We may not have time to actually fine tune, but we'll talk about how all of the principles I mentioned here also work for agents. So I'm done showing this graphic here, which kind of talk about our different offerings and how we work really well with our partners such as Microsoft Azure. So let's go ahead. I do want to note that if at any point you miss the details and also for some reason don't want to listen to Gerard's lovely voice, we also have documentation on pages on both weights and biases and Azure to go ahead and run through that same process, but from a screenshot perspective and some text. So let's actually go through an example now. So one use case I find really valuable and I'm excited to see more development on is the capability of using large language models to actually understand and streamline the process for people such as those in the medical field. But unfortunately, even though the LLMs are extremely powerful for a lot of different tasks, even for those that are related to the medical field, it doesn't necessarily match the expectation of a highly regulated field such as this one. For instance, in this example we'll be talking about today, we're going to be going ahead and condensing really long, unstructured patient and doctor dialogue into doctor's notes that we can use to actually provide to that patient and use as a medical professional ourselves to understand our next steps. So this ugly collection of text you see here is that actual unstructured documentation. So what I was mentioning earlier is you can see that this is in the same form for those of you who are AI developers, in the same form that you would use to interact with a large language model from an API perspective. As a reminder, it kind of looks something like this, where you would pass the messages to something like the Azure client, which interacts with your whatever GPT style model you like to use, or whatever LLM makes the most sense. And then you structure it in this format. But what we're going to do here is actually teach our model how to write this out, take this unstructured dialogue and make it in the form that we want it to for using less tokens and also ensure that it has the information we specifically want. So let's actually open that up here. Well, so specifically what I want are these rules to be built in from our model. So what we would do here is effectively take all that information we just saw there and curate in a list of examples that represent our ideal scenario. So what that means is I'm not only am I providing the raw unstructured transcript that I just showed earlier, let me hide this, all of this, but if I scroll down, we're also going to prove it, send it over the ideal answer that we want from this. You know, this is a bit hard to read, so I'm going to start showing you some of the weights and biases tooling. And you can have this nice interplay between Azure and weights and biases. So return to this screen is you can actually serialize whatever data sets you want easily within weights and biases. So over here, you can see this is actually the dialogue that we have. You can see on the left-hand side, we have the specific person talking, so the doctor or the patient, and also that interaction itself. So you can see here, a lot of this is like back and forth that isn't actually useful. And over here is the ideal response that we curated. So this note has a very specific structure here. Let's see if Markdown looks a little better. It does. As you can see, it has specific headers, all in caps. It has specific information we want that was taken from that dialogue. And then things such as review systems, any medications, and any examination information we find useful. So you see here, we have a very specific requirement for how we want this information to be displayed. So let's go through and see how a normal GPT model does. So as you can see here, this is what we call the observability trace tool. So this is useful for the capability of understanding the underlying thought process of our large language model application and to see where any errors could have occurred. So like in here, I provided as input to our model that unstructured dialogue, and without any fine tuning, this is the output from the large language model. So surprisingly, it does pretty well. If we were to actually go through and read all of the output here, we can see that it gives a response that semi-matches the information that we want given our prompt template. Our prompt template in this specific scenario is, if we are to go into here, it's something along the lines of extract these details from the medical records. And it has the raw text itself. So looking at this output that we see here, it's somewhat similar, but it doesn't actually look like that specifically structured note that we expect our human scribes to respond with. So our main goal is actually to make it look something like this. So after fine-tuning, we want it to look like a little bit more similar to the structure that we saw earlier, but instead of actually telling our large language model to do it that way, we're going to teach it via fine-tuning. So I got a bit ahead of myself here by showing you the comparison between the unfine-tuned model and the fine-tuned model. So let's actually go through and run through that fine-tuning process. So we're going to go back to the screen in the Azure AI Foundry, as we see here. We're going to verify that we have our key vault and secret appropriately connected in the Manage Integrations tab. And we're going to go ahead and fine-tune a model. So similar to what Gerard showed, I'm going to go in here. I'm going to go to something like GPT 3.5 Turbo. Just have a quick model to train. We're going to allow the initial screens to pop into here. So we're going to say yes to logging to weights and biases. I'm going to grab the project name I care about. I might give it a name such as demo project. Not sure if that we'll have time to see that populate in the screen, but you have the option there. And then we're going to upload our data sets. So in this case, I have our training data set here, which is the medical conversations. I'm going to pop in our test data set here. I'm just going to use all the default parameters here, except I'm going to use the only appropriate seed, which is 42 for our sci-fi fans. And then we're going to go ahead and just verify everything looks good here. And once it does look good, we'll click submit. And you'll see, as Gerard showed earlier, that our request is now queued. This is going to take a second, possibly. So I'm going to go to one of our older fine-tuning jobs. So when clicking into here, you actually get to see that there's a nice link to actually go to the dashboard once it's finished training. So if you go into here, you actually see that all these logs represent the data that we're saving. And you can actually see that, if I were to click over, that it did, in fact, validate that, the weights and biases project is running, and you have some information about it. And at the same time, you have access to the checkpoints and metrics from the Azure side. And so this is useful for understanding an individual experiment. If we actually go into the weights and biases dashboard here, usually we have a nice access to this information forever. And what's nice about this information is that from the weights and biases ecosystem, you have access to a lot of the tools that these AI developers will be using. So what I mean by that is you have access to understanding your experiments at scale. So in this case, what I can do is visualize all these experiments, for instance, and you can see all the different experimental runs that I see here. So in this case, I actually smoothed out our experiments. Actually, this will have no effect here. So let's actually go and make this look a little bit uglier for a second. So I'm going to turn this to 0. And you can see our models are kind of jumping up and down here. And so it's a bit hard to see whether our models are training effectively. So what I might do is use something like the smoothing function to see the generalized pattern of our model training here. There's too many models, actually, so I'm going to visualize none. I'm just going to show one, for instance. So you can see here that we have this curve that initially has some bad training that occurs. Let me zoom in here. So it kind of increases in this loss function, which is representative of our model's capability to learn. And I'm going to now reset that. I'll just reset the page. That's fine. I think double clicking want to fix that. And you can see though afterwards we have this nice curve that slants down and to the right. This is what we would expect to see in our model training. There are some bigger jumps than I'd like to see, and so there's probably some adjustments we can make to some of the parameters that we set earlier. But in general, we see the shape of the loss curve here mimic what we would expect from proper fine-tuning and training. And you can see that this is reflected also in the accuracy. But to also verify this, we had also some test data provided here. So you can see from our test data that there is some degree of that similar shape that we see above, which is what we want to see. But there are also some curves that go up and down over here that may require some more reflection on our part to see where these bumps are coming from. But overall, we see a jump of accuracy from 70% up to 76% after fine-tuning. So this is at least the overall improvement is reflected in our validation data. But maybe we want to serialize this. Maybe we want to make sure that when our boss or whatever important stakeholder of your project here for this medical scribe project we see here is verifiable, what we can do then is something like reports. So over here is I may want to go ahead and actually save all this information about my process into one readable format. So what I mean by that is I can have access to any code that's important, screenshots that matter, and even display these live charts within this Notion-like / Google Docs / dashboard-like experience. So for instance, if I were to run a new experiment, it would automatically be populated here. And then the readers of this page can go ahead and adjust what they see on this web page extremely easily. And more than that, you can go ahead and actually add comments. So you can say something like, hey, this is Huey, but hey, Steve, the blue model is definitely the one to deploy, for instance. And go ahead and actually add comments here. So you have a nice collaborative experience where you can have not just an individual experiment that is being investigated within your team, but you actually have this instead of one experiment, you can have all these experiments have that full context that's important to make key decisions about deployments. So now what I can do is go back to the AI Foundry, go to deploy model, for instance. In this case, I already have one deployed here, but go to deploy fine-tuned model, find the one that reflects the appropriate model that matters to after comparing all these multiple ones in that one dashboard and click deploy. So we can already see how this is extremely valuable to us. And what's nice is that after it's deployed, you can go into the chat experience here and actually test this out. So I would actually change this prompt template that we have here into something that's more reflective to what we told our model during the training process, which looks something like this. I won't do it from the chat side because it'll take some time, and that's not the experience we're here for. What we want to actually do is run evaluation to verify not only qualitatively, like we showed here, from comparing the input and output notes that came in from our dialogue, but actually look at the scores between them. So what's nice is after deploying the model in the Foundry experience, not only are you able to use it in the chat playground that's available here, but you actually use it programmatically for your AI developers. So here, this model you see here is our deployed model. And so what I can do is actually use what I was showing earlier in that qualitative comparison view, is use our weights and biases weave tooling to run evaluation that compares our fine-tuned model and our base model against each other with a set of examples of data and even something like a scoring function here to understand which model is doing better. So in here, we're using a concept called LLM as a judge, and I won't dive any further into that. I'd recommend looking that up. It is a very fascinating scoring mechanism they can use to compare LLM outputs. But what I'm going to do here is I'm going to go to the eval tabs here. I'm going to highlight both of these. I'm going to click compare. Instead of letting that render, I'm going to go to a pre-rendered view we have here. So what I have here is you can see that this pink bar represents the fine-tuned model that we have, while this blue bar represents the unfine-tuned model. So you can see almost immediately, also on this radar plot, that our model for the fine-tuned model is extremely, is almost 2 times better than the unfine-tuned model. But unfortunately, it seems like our fine-tuned model is a bit slower. And so the reason here is actually a fault of my own. And this is why it's useful to have views like this. This is because some of the parameters I set in the deployment side were not as effective as some of the deployment patterns that were set on the fine-tuned model that we used here. So in fact, I and myself in the fine-tuning process introduced latency, for instance. And so what's nice about this view is not only are you able to look at any scores that you would want to compare between these models, but you can also go and look at each of the same examples outputs all in one view, where in this case, you can see that the left-hand side represents our output from the, for this one dialogue you see here, you can see that this is the output that comes from the fine-tuned model, and this is the output that comes from the unfine-tuned model. So this is what actually does worse, as you can see qualitatively. So you can start to paginate through and see the different outputs between these models. So scroll down here. So you see, like, for instance, this one shows a structure that does not mimic the ideal structure that we saw from the note that we want our LLM to respond with. That to say that you can have both a qualitative and a quantitative view all available here, and ensure that you can point to and verifiably say for these high impact domains that yes, the fine-tuned model is in fact has a lot more improvement than the unfine-tuned model. And so what's nice is that this whole fine-tuning process I mentioned here is actually transferable also to something like an agentic workflow. And so for those of you who aren't aware, agents are effectively using a powerful large language model alongside tools and environment. And so what I mean by that is that the concept of an agent is that it will be able to self-reflect about the outputs it generates and make decisions about what steps to take. So what I mean by that is I can have an agent that, and so to keep it more medically based, is not only create notes about the dialogue that was presented to it, but maybe actually go ahead and put an order for specific medication for that patient. So we need to go ahead and not only generate notes about what happened between the doctor and the patient, but then understand that it needs to go into the database, find possibly the provider for that patient, and then put in an order for that specific medication after rereading the notes it generated itself. So all those are multiple steps that are not necessarily one-off. You can't just tell it to do the sequence always. It may need to take a second to go ahead and reflect about what steps it actually took. So let's see if I have a better diagram here. Sorry, I didn't want to show this. So like, this is an example called the React framework, called reasoning and acting. So reasoning and acting, for instance, has multiple steps before it reaches a criteria that says finish. So like in this example, it knew to search Google and grab some information, search another phrase and grab some information, search yet another phrase, and at each step, it reads its observation, understands that it did not solve the task that was provided in front of it. And so in this case, it says, I need to search the Apple remote. Apple remote was designed in a certain way. And then go ahead. Essentially, it has a process of continuously iterating on its steps until it reaches a finality criteria. And so natively, large language models are not taught to take this thinking process. So instead, what we need to do is teach that behavior to a large language model. And so that's where fine-tuning is still effective here. So a specific data set, for instance, that's useful for Microsoft is one called Orca Agent Instruct. If we actually look what that data set looks like, it looks very similar to what we provided in the medical example. You provide that full back and forth interaction between the large language model and the user until it reaches that finality criteria. So we can teach large language models to be better agents. And that's kind of what the Orca set of models released by Microsoft do. So like in the case of code generation, in this really not zoomed in screenshot here, you can see that there's a lot of steps that we can have our large language model take to actually reach a state where it writes good code. And so if we're to actually show that in a code sense, there's a lot of steps that it needs to take, such as draft solution. Actually, we'll do it from the side. Draft solution, analyze and plan solutions, generate solutions, reflect, improve, and etc. So there's a lot of multiple steps in which we need to have the LLM understand which action to appropriately take. And so, for instance, if we were to go ahead and fine tune a model in this situation for that, it still have similar charts as we see here, and would still use a similar workflow within the fine tuning portion of the Foundry here, where the only difference in this situation is for whatever model you choose, you just need to make sure that you take this information as we see here, ensure it's in that OpenAI format that we can see is already in this specific case, and just upload that agent tuning, and upload that ourselves. Where's the upload button? Upload that ourselves in this specific situation that we see here. I won't run that fine-tuning process or show that example here due to time constraints. So instead, what I'm going to do is actually open up the floor for any questions for the time we have remaining, and see if there's anything that we can explain more about fine-tuning, the process of understanding charts from the fine-tuning process, anything from the fine-tuning workflow that matters, and also the theory or concepts around agentic workflows. For any of those you want to try out the code gen examples here, there is a AI Hacker Cup repo within the WandDB to let you try out these code gen style of agents. I'd love to see you fine-tune your own on the Foundry and share those examples with us here. So yeah, I'd love to hear any questions. And if not, thank you for listening. But let's go see if there's any examples here. Also, yes, to mention some questions I already asked earlier. The process of fine-tuning does in fact adjust the weights of the model that is that base model. And so the specific one we have here is we use a technique called low rank adaptation. This is a very interesting mathematical approach where what we do is actually decompose the process of fine-tuning into more of a matrix multiplication problem. And the reason I say it that way is because there's a lot more interesting math and algorithmic approach there. But in general, fine-tuning is a really expensive operation if you were to simply do it natively. So we now, because of how large these large language models are, it's not as easy as throw it on a GPU and fine-tune it. Instead, it's a little bit more effective to say, load the model as much as possible and use interesting techniques to pinpoint where we can make improvements upon and save that elsewhere. So whenever we want to go ahead and provide a fine-tuned model, in this situation, low-rank adaptation doesn't simply say, here's a brand new fine-tuned model. Instead, it says, here's our memory card that we can plug in to this fine-tuned model that only reloads a saved version of that fine-tuning on top of the fine-tuned model. So it's really cool. Would recommend looking up some literature on it. It's pretty intuitive if you look at some graphics that I don't have available here. A second question is, what is distillation? So distillation is essentially compressing a big model into a small model. So for instance, GPT-4o is a really powerful model. But also, because it's more powerful, it's a bit more expensive and a bit harder to deploy, for instance. So if I wanted to make GPT 3.5 Turbo, which maybe not the best one anymore, but let's use that one still, GPT 3.5 Turbo to have the same level of capability as GPT 4o, but maybe for only specific situations, then distillation is the concept of taking outputs of ideal responses from 4o, showing it to 3.5 Turbo in a fine-tuning style way, so that 3.5 Turbo is now better at that one effective new task that we extracted from 4o, and do that in a very cost-effective and performance-effective manner. And so that's really useful, for instance, for edge devices. Distillation is extremely useful, where you want maybe like an edge device on your phone, for instance, to have very specific good capabilities of like reading your email from your mail app a lot better without having to load in or communicate with a 4-hour model and in a very latent, slow latency perspective. And also to compare distillation to transfer learning is the concept of teaching new behavior to a model, while distillation is compressing behavior from another model. So they're highly related, but not the same, for instance. Another question is, where is weights and biases data center? So weights and biases allows you to be deployed anywhere. So we partner with all of the important cloud providers, including Microsoft. And so we actually released a new ISV native integration, for instance, within Azure, which allows you to essentially spin up your own version of weights and biases within your own tenant on your Azure instance. That to say that the data lives where you want it to live. There are on-premise versions. That's if you want it fully air-gapped, or there are also managed deployments if you want us to help you with that deployment yourself. What is the best way to get started with Azure OpenAI for increasing the efficiency of Terraform infrastructure as code deployment? So I don't know the specific of that question itself. I think I'm misreading it. I don't know if that's a back-end question for Gerard on how to use Terraform to help set up Azure OpenAI, for instance, or if they're saying, can I use Azure OpenAI to go ahead and do stuff to make almost like a co-pilot to make Terraform code deployment easier. So I'll answer the second one, maybe, where you can, in fact, for sure, spin up a Azure OpenAI deployment yourself and have it either fine-tune it to be better for Terraform, for instance, by using some of these code repos that have different languages or like different examples of ideal solutions. And then have that as part of your own Copilot experience in something like Visual Studio or whatever you use to experience from the software development side. But I'll let also Gerard take that first component. Can you use Terraform to help easily spin up your own deployments of Azure OpenAI, for instance?
I mean, absolutely. I'll be honest, I haven't done it, but I'm pretty confident that you should be able to do that. And you definitely, Azure itself, Azure Portal has its own Copilot, so presumably that could even help you do so. Yeah, I would totally expect to do that.
Cool.
I was going to say, the following question, what's the difference between fine-tuning a model and training a model? My best guess that would be the amount of data. When you're pre-training a model, you're talking huge amounts of data. I feel like this is one of the places where I know too much to say too much. So I'll just say, you can fine-tune with as little as 10 rows of data. I can't promise it will be highly effective, but you can fine-tune with a small amount of data. If you're building your own model, you're doing a lot more than that. Can fine-tuning be used for learning new data? Absolutely, you can teach them that. And there's a bunch of papers that go into how effective these models are at, fine-tuning is at teaching new facts. There is a scale trade-off on this where if your domain is such that it is static, it can sometimes be worth using fine-tuning and teaching new facts, though often there's a trade-off between RAG and how to do that. The general recommendation, and this is general, it may not be applicable to your use case, is probably for learning new data that is likely to change, you would use RAG, but if it's formatting or domain knowledge, you would consider fine-tuning as the better solution.
And like one thing that is useful is almost combining both. So there's a concept called Raft, which is fine-tuning your large language models to interact with this new data better. So what that means is, like, let's say you store your data in a very proprietary way where you have specific queries or ways that you retrieve that data. You can teach that interaction to a large language model. So instead, you can make RAG better for your new data and use a mixture of a good vector database, but also really strong retrieval by using those very few examples that Gerard mentioned. And so that's how you can combine all these pieces together.
And something for prompt engineering as well. It's kind of, there's been a lot of arguments of which is better. Well, it turns out it's all of them. You use all of the skills. And if you're balling out of control, I guess you could pre-train your own model. Yeah,
if you have the compute and have a bunch of H100 clusters, have fun. That is something that most people do not have. So take advantage of that. Okay, it seems like there are no other questions popping in chat. I'll give it like a minute more, see if anyone else has anything to say. But if not, thanks everyone for joining this session here. Hopefully you're able to learn a lot more about not only fine-tuning models, but also understanding the new capabilities of Azure AI Foundry and how it works really well with weights and biases, and can actually use this for a plethora of use cases outside of not only like things such as highly regulated industries like medical industries, but also how agentic applications are in essence LMs fine-tuned to take specific actions, and you can do that yourself, all using the same workflows that we saw here. Okay, with that, I would say that thank you, everyone, and hopefully you go back home and build some really cool stuff.
Yeah, thanks everyone. Can't wait to see what you do with it.